Hey everyone, welcome back to my another logistic regression tutorial. This is 8th part, and in this part we'll merge all functions into a final model. So in this tutorial we'll see what we need to do to fully train and test our model. Before structuring our model, I'll clean my previous tutorial code, so I'll prepare it for this part. So I'll comment my all testing parts. So I'll begin from the start, and we'll use our real data set. We won't use our custom data, and what we'll need is, so we'll need this, and we won't need this print, and I can delete them simply, and I think I'll do this. So yeah, maybe it's better to delete what we won't use, but I might forget if I delete something useful, it might be bad. So let's comment them simply. Okay, and we are working with our data here, optimize, predict, and so on. Print, we won't use this print anymore, and when I'll upload them to my text tutorial, I simply remove our not needed code. I'll copy them to the beginning, somewhere here, just like that, and I'll comment them here. So give me a few seconds. Okay, just like that. So at first, what we'll need to do before defining a final modal function, we need to define one more helper function. So this will be our initialize with zeros function, and here is our dimension, what we want to initialize with zeros, and here will be our weights equal to num by zeros of dimension by 1, just like that, and here our bias will be 0 and return weight and bias. This will be our one helper function. And now let's build our final modal function. So define a modal, and what we'll use here is xtrain dataset, and here will be itrain, xtest, and itest. And here will be similar to our what we have here. So xtrain will be train set x, itrain will be set text I, whereas it will be train set I, train set x, and test set x, test set I here. So what we need here more is the number of training iterations. So default will do it like 2000, and learning rate will be for us default 0.5, and okay, we'll use a print cost as before, will equal to false. So right now what we need to do is we need to initialize parameters with 0. So our weight and bias will be initialized with zeros, and we choose here a shape. So here will be x train dot shape of 0. So this will be simply this shape. Well, anyway, doesn't matter. You can scroll back if you want to check what it is, or you can just print it here. What is the shape? X-train shape 0, but it will be big number. It should be something like that. And now let's simply train our model. So what we need to do is we need to call optimize function. So we already used it on somewhere. So here it is, optimize, and here we called it. So let's simply copy it. Params, let's call it parameters, grads and costs, and here will be optimized by VB, and here we'll change it to X-train and I-train. Here will be our default number of iterations, just like this. Learning rate also will be chosen by here, and print cost also chosen by here. And next, after this, we simply need to take our parameters of weights and bias. Here should be already our trained parameters of 2000 iterations if we choose default, and that's it. So everything takes place in here. So next, let's predict our test train examples. So what we will do is just write I prediction test equal to predict, and here will be W B X test, just like that. And we'll do the same for our training. So here will be train, and here simply predict WBX train right now. X test, here was an X train, just like that. And now we need to print our accuracy or error, I don't know how you call it, it's up to you. So we use a print function, and here I'll call it train accuracy equal to like that number, and here I'll write a format. Here will be our 100 minus numpy min. Here will be number ABS, absolute number, and here is our I prediction test or train I prediction train minus I train, and next we multiply it by 100%, just like that. And we print the same accuracy for our test data, format, numpy min, prediction, and here I'll choose test and I test. Just like that. And here what we do is simply we have here labeled data here, I trained for example, and we know where is a cat and where is a dog, and here is simply similar data but with predictions, and here we just calculate the difference. For example, if there was 1 and we minus 1, it will be 0. But if, for example, there was here 1 and actually it was a 0, so there is a difference by 1. And here we calculate 1 and we simply abstract it from 100 and then we calculate it in percent. That's it. That's quite simple. So next we'll use a dictionary to return, and here I'll just write for example costs, and here we'll return our dictionary of parameters. And here will be I prediction test equal to I prediction test. Next will be our I prediction train and I prediction train. Then will be our weights, and here will be also weights. Then we calculate a bias, and then learning rate, just like that, and number of iterations. So that's it. This will be our full dictionary, and last thing what we need to do is return dictionary. So this way we'll return a modal as a dictionary, but mostly what we need is weight and bias. These are just for interest. So right now we defined a full modal. Oh, here is some kind of mistake. So here it should be just like that. And I hope there is no more mistakes. And next, what need to do is we need to call it simply to train our model. So what I'll do is call it. So here will be our modal, and I'll just copy it for simplicity, just like that, and it will return D as modal. Here I'll just copy my test and train data, train set I, and then will be test set X, test set I, number of iterations I'll say set 2000. For learning rate I'll choose quite smaller, and print cost, okay, we'll choose it as true for us for now. So with this one line we'll train our weights and biases for detecting cats and dogs. So before training I'll do one more step. Here in my folder I have a cat JPEG folder, image, and as you can see here is simply a cat, and we'll try to write a simple test mode, so we'll test if it's a cat or not. So let's write a test image will be equal to cat JPEG as you saw before, and here is my image I'll call, and I'll call a read image function as we wrote before, and here will be my test image, and I'll read my image with this one function, but then I need to reshape it. So I'll reshape my image that it could be used for prediction. So here I'll transpose it, and now I need to get a shape of my image. So if you remember what is the shape, you can check yourself, but I'll do it by copying, for example, from somewhere here. So wait a moment, I did this somewhere else. Okay, I'll just call reshape function. So here it is, rows, calls, and channels, and I'll just have here a shape of this. You shape it to this format, and now I'll call it my predicted image. Image will be equal to predict function, and here will be my D, here will be my weights from my dictionary, and D and weights from my also same dictionary but bias, and here will be simply on my image. And next, final step is I print my predicted image, but we need to do numpy squeeze before doing that, and my predicted image, just like that. So my predicted image, predict, why you call this predict? So here we wrote a function, what we do here, and here we use our weights, biased, and simply an image X. And we use for our propagation, for our prediction. So that's it for now. And yeah, I think let's try to build this and train. So this might take for a while, but if we'll take it for, oh yeah, hello, we have an error here. Okay, let's see what we have here. Num iterations. Okay, number of, we have something wrong in dictionary. Oh yeah. So what's wrong here? Oh, sorry, I forgot this. Yeah, sometimes we do silly mistakes. So let's build it again, and we have another mistake here. Okay, and I don't, yeah. Okay, let's build this, and let's see if we'll start building. It will take for a while because there's 2000 steps and my processor is not very powerful, and if it will take for a long time, I'll just stop the video or make it faster when you start watching it or something like that. So right now it's simply loading an images because there is a lot of images. I think 6,000 of training images and 1,000 for test images. So right now it's just loading, and yeah, hello, another error. Okay, what we have here, initialize with zeros. Oh, okay, let's build it again. I didn't thought about that there might be some another mistakes, but let's see what we'll get. So right now it's again loading data, and we'll see. Let's wait for a short amount of time. So it started training, as you can see, and we have a cost after 100 iterations. And okay, we'll see. Let's wait for it to continue of training. We have an error, what I thought we might get. So I made something wrong while reading my image. That's my mistake, and I'm sorry for that. But as you can see, at first we had finished training our model, and as you can see how we have a training accuracy of 66% and test accuracy at 60%. So this is quite fine for our logistic regression and for such a large database. So it's a little better than random guessing or rolling the dice. So 60%. So what we need to do, we didn't finish this step yet, so because I wrote it bad with how to read my image. So I'll check my again one function, and no, we are not reshaping an image. Or we don't reshape it, we just resize it. So sorry for this. Let me think for a short amount of time. I'll just stop video over here. So I found where is my bad. So simply I wrote here channels, and here should be channel, it should be channels, and here is double quotes, what we don't need. And now, before we did 2000 steps, right now I'll do 3000, and we'll see what results we have. I'll stop the video here and we'll return after we finish training. So we are back here, and what are the results? Before, test accuracy was a little bit better, and train accuracy I don't remember exactly, but as you can see, with 3000 steps it didn't improve very much. So what is left is to test our learning rate. And as you see, what was the prediction? So my prediction image was 0, and 0 I think means the cat. Where is my function for preparation of dataset? So here is, if 0 it means a cat. So our model predicted it right, so there is a cat. So congratulations on building our first image classification model. This is the final model which you can train for yourself and test it on different datasets. It shouldn't be used only on cats. You can use it on humans, on cars, or whatever you want. It doesn't matter. But at least this is one neural network. So it's not a network, it's just a perceptron. So sigmoid logistic regression. So in next tutorial we'll do one more. We'll analyze it further, so examine possible choices for the learning rate. So I'll show you how to train better model by choosing a better learning rate, and you'll see what is the difference when we choose a different learning rate. So that's it for this. Keep reading my text version tutorial. It is more clear and more detailed and so on. So keep following me on YouTube, like my videos, subscribe, and wait for another future tutorials. And thank you all for watching. Good luck and see you next time.